Hey guys, today you're going to talk about writing equations for lines. So our goal today is to write equations for lines in slope, intercept, and point slope forms. So example number 1, we want to write an equation of a line with a slope of -2 and passes through the point -1, 3. So for example number 1, the slope is -2. That's coming from right here. The point that we're working with is -1, 3. And all I did was label it with x and y. We're going to use our slope-intercept equation, y equals mx plus b, and we're going to substitute in what we know. So we know the slope is -2, so that's going to go in for m. And then we know an x value and a y value, so we're going to sub those in as well. So we're replacing y with 3 from the point right here. The slope is -2, so it's replaced with -2. And x is -1, so we sub that in as well. And b is what we're solving for. We don't know what b is. So -2 times -1 is a +2. Then our goal is to solve for b. So we're going to subtract 2 from both sides of the equation. So 3 minus 2 is 1, and we're left with b equals 1. So when you're done solving and you find what the y-intercept is, you need to substitute that back into your equation using your slope. So y equals, here is our slope, -2x, excuse me, plus 1. Okay, so this is the equation of the line with a slope of -2 and passes through the point -1, 3. All right, example number 2. We want to write an equation of a line containing the points A is 1, -3, and B is 3, 2. So start by labeling your points, x1, y1, x2, y2, and we first have to find the slope between those 2 points. So y2 minus y1, remember there's that double negative, so be careful there, over x2 minus x1, so 2 minus a -3 turns into a 2 plus 3, which is 5. 3 minus 1 is 2. So the slope is 5/2. You can leave it like this, or you can change it to a decimal if you need to. Then you're going to do the same thing we did over here. Start with y equals mx plus b. And you pick which point you want to use. It doesn't matter. You can pick point A or pick point B. It's up to you. I used point B. So y is 2. I substituted that in. Equals our slope we just found is 5/2 times our x value is 3 plus b. You need to multiply these two numbers. So 5/2 times 3 is the same thing as saying 5 times 3 over 2 times, and then there's a 1 underneath here. So 5 times 3 is 15. 2 times a 1 is 2. So 15/2. Our goal is still to get b by itself. So we're going to subtract 15/2 from both sides. In order to subtract, we need a common denominator. So the common denominator, use the 2 that we already have. So we would multiply the numerator times 2, multiply the denominator times 2, and that's where this 4/2 came from, minus 15/2. So subtract across the numerators. 4 minus 15 is -11, and the denominator stays the same. So 4/2 minus 15/2 is -11/2. Then you're going to take your two pieces you found. We found our slope is 5/2, and our y-intercept is -11 over 2. So our equation, to put it together, y equals 5/2x minus 11/2. All right, example number 3. A technician is using a coordinate grid to design a schematic for a circuit board. A connection aligns with the line shown below. Write the equation of the line. Okay, so this is what we've been doing for a while. We want to write the equation, y equals mx plus b. You can see right here, the y-intercept is 3. Okay, a positive 3 because you went up. That's where this value comes from. Then you want to find your slope. Right here is a point. And remember, you want to find where they cross and make that T. So right here is another point you can use, right at 1, 1. So from here, we went down 1 time, 2 times, so down 2, and then over 1. Same thing I'm showing you over here, down 2, over 1, negative 2 over 1, simplifies to negative 2. So our equation of the line, y equals negative 2x plus 3. And example 4, we want to write an equation of a line parallel. So whenever you see the word parallel, you want to think same slope, to y equals negative 1/3 x plus 1, and contains the point r is 1, 1. So like I said, parallel, same slope. The slope of this equation is right here, that negative 1/3. So that's the slope we want to use. We're going to substitute that in to our y equals mx plus b because that's the slope we need in order for it to be parallel. Then it wants it to go through point r, which is 1, 1. So our x value is 1 and our y value is 1. So substituting in 1 in for y, you get 1 equals negative 1/3. Substitute your value of x, which is 1, plus b. Remember, do not continue writing x once you do your substitution. Negative 1/3 times 1 is just negative 1/3. So you have 1 equals negative 1/3 plus b. We're still trying to get b by itself. So the inverse operation, so negative 1/3, inverse operation would be to add 1/3. So add 1/3 to this side as well as to the left side. Okay, so we're working with fractions again. You need that common denominator, which is 3. So I'm going to multiply the numerator by 3 and the denominator by 3, and that's where this 3 over 3 comes from. If we were to work backwards, 3 divided by 3 is 1, and we're back to our original. Okay, so we didn't change the value at all. Plus 1/3. Add across your numerators. 3 plus 1 is 4. Keep your denominator is 3. So 1 plus 1/3 is 4/3. And that is our y-intercept or our b value. So you're going to take this and substitute it in right here. So you get y equals negative 1/3 x plus 4/3. And there's our final answer. All right, so those are your notes for today. Now you're going to work on the classwork assignment. Make sure you are using your notes to help you and showing your work. So your classwork assignment for today is just workbook 6.3. You are doing all of it. Okay, so you're doing the whole page. You're writing equations. These are very quick in slope-intercept form. Then you're going to write an equation given the slope and the point. You've got a couple graphs to write the equations from, and then lastly parallel. We didn't do an example like this. This is why I want to show you. Perpendicular. So remember when we're doing perpendicular lines, we want the negative reciprocal. So for instance, if this had asked for the perpendicular line, we would have found the negative reciprocal of this slope, which would have been a positive 3. And we would have substituted 3 in here, okay? It didn't ask for that, but just keep that in mind when you are working. Have a great day.